over b, and b is 1/2, so the period is 4 pi. Let me deal with that much, and then we'll come back and deal with the phase shift. So, how do I deal with this period change of 4 pi? Let's think about what's happened is, the period of cosine is normally 2 pi, but now it has been doubled. In other words, this point here on the normal cosine curve, instead of being at 2 pi, is now going to be out here at 4 pi. But in addition, the amplitude has been changed. So the point that it's going to end is now going to be at 4 pi and up to 1/2. Let's take some other key points. For instance, let's take this minimum value of 1. Of course, first of all, it's only going to be 1/2, but instead of being at pi, again, this has been stretched by a factor of 2, so it's going to happen at 2 pi. So negative 1/2 and my 2 pi. Let's pick the intercepts next. Let's start with this intercept. Instead of happening at 3 pi over 2, it's again been stretched, so by a factor of 2, so the 2's cancel, this intercept happens right here at 3 pi. And this intercept that's normally at pi over 2, stretched by a factor of 2, the 2's cancel, and we know that it's going to go through pi. And finally, let's take this point here, which actually the only change is going to be that it's half its distance, that is half the amplitude. So, this is not the final curve that I'm about to draw, but it's the curve that's adjusted for both the amplitude and the period changes. And I'm going to draw it in a dotted orange or dashed orange. So it would look like this. And that would be the curve with an amplitude of 1/2, but a period of 4 pi. Well, what about the phase shift? The phase shift, if we look back up at the manipulated equation, x minus pi over 2, tells me that my phase shift is pi over 2 to the right. Pi over 2 to the right. So let me write that down. Phase equals pi over 2 to the right. All right, so what I'm going to do is take the key points that I've just drawn in the orange chalk and shift them to the right by pi over 2. So this point, instead of being here, will now be at pi over 2. This point would be, instead of at pi, 3 pi over 2. This point, which is right now at 2 pi, is going to go to halfway between, or in other words, it's going to go to the equivalent of 5 pi over 2. So let me write that in. Okay. This point here is, again, going to go halfway. So it's going to be an intercept at 7 pi over 2. And this point would shift over pi over 2, or in other words, to 9 pi over 2. Just for the purposes of what we're drawing here, we want one full period. So, and that is, in fact, one full period. So it would start here, and it would come down through the intercept. It would hit its minimum point here, go up through the intercept, and hit the maximum point there. So you can see that what's happened is we've shifted the orange curve over to the right by a shift of pi over 2. So the only thing left is the vertical translation. Well, let's take a look at the equation and see, well, there is no vertical translation because there's no value of c that's being added or subtracted on to the function itself. So there's no vertical translation. This is, in fact, the pink graph is, in fact, our final graph. Great job. That was a lot of work. You did yeoman's work today. Now, in this section, you learned how to graph sinusoidal functions and how the amplitude, period, phase shift, and vertical translation affect the basic curves of y equals sine x and y equals cosine x. Sinusoidal function model many types of periodic behavior, and applications of sinusoidal functions are introduced in your text. Make sure that you do the exercises that your teacher assigns, and we'll see you next time.